Thanks everyone for joining us today. And today I'm really excited. I have spent time learning K0S project with my guest, Jussi Nummelin. He is a senior principal engineer at Mirantis. And also the one cool thing about him that he's also the team lead for the K0S project. We have met last time in January 2016. We covered what that is, K0S project. And thank you for Jussi for spending his time with me tonight. And tonight we'll be exploring what's new ever since last met. And tonight we're exploring K0S deep dive with HA environment and also how to do a multi-node setup in K0S project. So now without spending more of the time on introduction, let's go to Jussi. Jussi, how are you? And thank you very much for connecting me. And now it's party is yours.
All right, thanks for inviting me, and thanks for sort of pushing me to do this. Should do these sort of sessions more with the community and of course with you too. So yeah, let's have a quick-ish look at what's new in K0 since we last recorded this session. It was in January timeframe. So of course, K0 being a somewhat young project, still a lot is of course happening around it. So there's plenty of cool features and let's see what they are. Now my clicker is broken again. Okay, let's do it the old-fashioned way. No, everything's broken. Maybe. No. Okay. So yeah, I'm Jussi Nummelin, and as mentioned, I'm here at Mirantis. I'm the team lead for the core K0 team, and I've been working with containers and cloud native stuff for quite a few years, and being a hard-headed person, I'm still enjoy working with containers and Kubernetes and all the things cloud native, and really excited to build K0s now as the tool that helps people to use and adopt Kubernetes and all these other cloud native stuff. Of course, the standard legal disclaimer. So whatever I show and talk is of course not sort of legally binding in any sense. Just a couple of words about Mirantis, because well, Mirantis is the main sponsor sort of for the K0 project. So Mirantis is of course working with on sort of premise of ship code faster. So building the tools and technologies that allows you to adopt all these new DevOps and cloud native mantras on both public and private clouds. And of course we're heavy hitters on the container and Kubernetes side of the story nowadays, and that's where a lot of the effort goes into, just to build tools and technologies that allow people and organizations to move faster and adopt the technologies faster. Just a couple of words about K0s. So what it really is and what it maybe isn't. So K0 is really it is a Kubernetes distro, and it is a pure upstream distro, and by what I mean by that is that it is really the vanilla upstream Kubernetes stuff. So we don't do any forks, we don't do any changes on the upstream Kubernetes. So it is what it says in the tin. So there's no tweaks or anything. The packaging is done as a single binary. So the single K0 binary file has everything that it needs to operate. It brings along all the Kubernetes components. It brings all the container D binaries and everything. one of the main reasons why we wanted to build K0s from the start is to allow a distro that has like super versatile deployment architectures. Because what we've seen in the past year, maybe it started even like almost like 2 years ago, is the fact that Kubernetes is going to places where it probably wasn't sort of designed to go, like towards the IoT and edge type of use cases, for example. And in those cases, there's quite a few use cases where you don't really you can't really do this sort of a typical deployment model. So we have to have a lot of versatility on the deployments. And of course, we don't really want to deal with OS Linux distro level dependencies, because as we all know, those are painful to manage. But on the other hand, we kind of wanted to also have K0s as kind of as simple as possible too. So we don't really want to bundle like too many of these add-on components like ingresses and CSI volume providers and whatnot, because honestly, we as the developers for K0s, we cannot make the choice for you for what ingress you should use or what volume provider you should use, because there are so many different types of use cases which have different kind of requirements for those components. So we really want to have this as simple as possible. I mean, it always feels wrong to use the word simple with something that has Kubernetes in it. So one of the main sort of technical differences between many other Kubernetes distros is actually about the versatility. And in K0's case, we have this sort of true full control plane isolation in the picture. So but by default, when you spin up the cluster, and I'm going to show this as part of the demos today also, but when you spin up the cluster, the control plane nodes, they don't run any of the workloads. So on a control plane node, there's no containerd, there's no kubelet, there's none of those components available that would actually allow you to schedule your workload on the controller node, either whether you would do it on purpose or by accident, because that's actually one of those things in Kubernetes that's super hard to achieve. So having sort of all that in mind, we think that the K0s is actually a really good project to sort of have as a base for higher level stuff. And by higher level things, I mean solutions that then bring on these ingresses and volume providers and whatnot needed tools for let's say, for example, edge use cases or IoT use cases. We've had pretty good early traction when we launched the project open in November last year. So we've had almost 7,000 downloads for the tool, and we've been kind of from the start, we've been kind of overwhelmed a bit about the number of GitHub stargazers. I know it's a vanity number, but as an open source project, it actually does mean quite a bit, at least mentally. But all right, so today we'll focus on what's new since the last time we met in January. I'll share some ideas what's next also in the pipeline for the core team to work on, and of course there's going to be demos and also live demos. So be warned about live demos turning into a debug session. So that's how it goes. I like to live on the edge. So what's new? I've been collecting into this this what's new list here only the sort of the bigger and kind of more important stuff. Of course, we've been doing a lot of bug fixes, of course, and some minor other minor features and whatnot. So one of the main things is a tool called K0S CTL, and I'm going to be diving into many of these in the demo and on a couple of slides too. So K0S is really a sort of a accompanying tool for K0S to kind of make the life easier for multi-node setups. We've done a feature called what we call dual stack support. So basically you can set up a IPv4 IPv6 dual stack cluster. And by dual stack, what it means is that the pod, for example, a pod gets both IPv4 and IPv6 address. So basically the pods can and the workloads can sort of like choose that okay, whether they use IPv4 or IPv6 for the communications. Of course, for this you have to have an infrastructure that actually does support IPv6, but I think many of the cloud providers nowadays support that, like Amazon does, and of course I always my head is always going to say packet, but the Equinix Metal also has it out of the box, and many others too. We've also embedded kubectl into the K0S binary. So basically, what it gives you is a simple subcommand called K0S kubectl. So you don't have to go and download kubectl anymore on the controller nodes if you don't want to. Of course you can, but you don't have to do it anymore. We now support Airgap setups. So basically you can set up K0S in an environment where you don't have internet connectivity and you cannot go and pull the system images, for example, from the public image repositories or registries. ARMv7 is now supported as an architecture. So now basically out of box we support both AMD64, ARM64, and ARMv7 as the runtimes. Backup and restore for the day 2 operations, and then kube-router as a new default CNI implementation. I'm going to dive into some of these now with some further slides. So, of course, one of the big things that we did during this springtime is we actually announced that K0S is now generally available. So basically we now have a like a production ready stamp on it. So and of course for us the main thing that we wanted to have in the project to kind of give the production ready stamp, it's of course we had to have the sort of day 2 operations and operational capabilities built into the project itself, like backup and restore functionality. Of course, you cannot say that something is production ready when you cannot take a backup and restore a backup of it. And of course, what it also means is that we have quite a good stability on all the sort of interfaces, and one of the main interfaces being, of course, the configuration format. So we're not planning to do some radical backwards breaking changes on that anymore. Versioning is changed now a bit. So now the versioning actually follows the Kubernetes versioning. So basically we wanted to make it like 120% clear and sure that what is the Kubernetes version that K0S will actually spin up, because that's the main thing that K0S does. So it should really be evident from the version number and everything that okay, what is the Kubernetes that you get. So the plus part, the sort of a, if we follow the semantic versioning principles, that's actually called the build stamp. So there we have this K0S.x. The X part, there actually means that's the X release for this specific Kubernetes version. So now we have, for example, the latest K0S release is 1.21.1 plus K0S.0. So that's the first release for the 121.1 Kubernetes that we've done. So if we do a next release with the same Kubernetes version, the latter part will be then K0S.1 and so on. K3S actually follows the same versioning scheme, or not exactly the same, but pretty much the same versioning scheme, and it should follow and fulfill all the semantic versioning principles. I had to read the semantic versioning spec quite a few times to figure out that how we should actually do this, but if you see about the releases on GitHub, and if you see some of the release candidate and beta builds that we do, the versioning feels slightly weird, because the semantic versioning actually says that if you have a -rc indicating a release candidate build, for example, you have to have the -rc part before the plus part. So then the plus K0s and RC, they're kind of at least in my head it feels wrong, but that's just how semantic versioning forces us to do it. So, but yeah, that's the main reason why we wanted to do it this way. One of the main focuses for today, and especially in the demos, is this K0S CTL tool. So it's really a sort of a cluster bootstrapping and management tool for K0S specifically, of course. It really is built to simplify and of course fully automate the multi-node cluster setups. So maybe you remember from the last session and from the demos. So basically, when you create a cluster, you first boot up the controller. Then you take the token out from the controller, somehow transfer it to the worker nodes, and then you boot up the workers. So the process is actually quite simple and straightforward, but you don't really want to do it for 10 different nodes. I'd lose my mind on the third node already. So it's really about sort of automating and sort of building an orchestration sort of over that part of setting up and getting the tokens and whatnot. So of course but it's not only about the bootstrapping of the clusters. It's also about the day 2 operations. So what if I want to upgrade my cluster for the next K0S release? So the K0S CTL can actually do it and kind of orchestrate that. So what it does is that it first upgrades the controllers one by one. So say you have this 3+3 setup where you have 3 controllers and 3 workers, for example. So it upgrades one of the controllers at a time. So 2 of them are still available and serve and watch over the cluster. and then it goes and upgrades the workers with this usual Kubernetes train on cordon functionality. So basically we throw the workload out of the node, we upgrade it, and then we put it back into a schedulable state and whatnot. So essentially we try to make it as 100% available as possible. I mean, it's of course we cannot do magic if your workload is not fully highly available. Then we cannot do any magic tricks to make it like a fully available rolling upgrade. But we try to do it as well as possible. We can do with basically with the constructs that Kubernetes gives us. What I'm going to also show in the demo is the fact that we've designed the K0S tool in a way that you can actually include it and integrate it super nicely with infrastructure automation tools. So say you manage your infrastructure with Terraform, for example, which is kind of the de facto standard of doing that. So you can actually easily manage your infrastructure with Terraform and then just spit out a YAML configuration from Terraform, and the K0S CTL will actually take it in as is and operate the higher level stuff on that higher level, meaning K0S and Kubernetes now. And of course, as it is a CLI tool, so it's of course super easy to integrate to any scripting and any deployment pipelines, for example, you might have or anything. So it's super easily integratable with many things. ARMv7. So as I already mentioned, we in the past year, couple of years, we've seen a lot more traction in the IoT and edge type of use cases with Kubernetes, and in those sort of environments, the ARMv7 variants are actually super common. So, for example, if we think about these industrial environments where you have like your production lines and whatnot, and then you have controllers on the production lines controlling the processes and robotics and whatnot. Quite often those controllers actually have ARMv7 variants running Linuxes already today, so we definitely wanted to build ARMv7 support also in the K0S, and of course it's ARMv7 is also quite common in this sort of a hobbyist setups where you have small Raspberry Pi like devices on people's desks and whatnot. So definitely that's a common use case that we've seen also. For K0S, of course, because Kubernetes and all the upstream components, they do support ARMv7 out of box. So for us, it was mostly a sort of a build pipeline setup. So making sure that we actually run some automated testing on ARMv7 and also making sure that the release pipeline is capable of spitting out a ARMv7 capable binaries. Well, mostly. Of course, things are not that simple in real life. So there was couple of things we actually had to do for K0S. One of the biggest things that we had to make sure is that the CNI plugin that we ship with has actually ARMv7 support out of box. And this was for us. This was one of the biggest motivations of actually switching the default CNI provider in K0S to be kube-router. So unfortunately, if nothing has been changing in the past couple of months, Calico still doesn't ship with ARM v7 capable images out of box. I know that there's been a lot of community effort pushing that to actually happen, but I don't think it. I haven't checked the last release, but to my understanding, it's still not there. So one of the other things with kube-router is that by different benchmarks, it's actually one of the CNI plugins with the least amount of resources used by default. So it uses quite a I don't know significantly, but at least measurable. It has a measurable difference between other CNI providers of having a lower CPU and memory usage out of box. And if we think about especially these like ARM v7 types of devices where you don't really have like too many CPUs and you don't really have too much of memory, you definitely wanna take like every kilobyte that you can shave off. So that was one of the drivers also for the default change. I actually have it on my desk. I have couple of ARM v7 boxes. I can't unfortunately tell too much details because this is actually connected to a still private customer case that we have, but those boxes have actually only one CPU and they have 500 megs of RAM. So, and I do have K0S running there, so we can actually with this sort of small changes we can push the envelope quite a bit actually. So this is looking pretty cool. About Airgap setup, so of course for K0S itself, there's pretty much no dependencies by itself. So of course we do need all the sort of a container building blocks available on the host kernel and whatnot. So but you don't have to go and install a gazillion different other packages and whatnot. So. But the main thing that we need for the Airgap environment is basically the images for the system components. And by system components, I mean the kube-router, CNI provider, the metric server, kube proxy, core DNS, and then those sort of components. So basically now we have the special varlib K0S images folder where you can actually drop this tarball of images. So and when K0S starts, it actually then first, or when the worker starts, it first bootstraps the container D as the engine, and then it sees that, okay, hey, I have this one image tarball in this special directory, so it'll actually import the images to container D and to the container D image store. And of course, we do bake ready-made bundles for these system images as part of the release pipeline. So you can actually go and go to the GitHub releases and download a ready-made tarball for you, so you don't have to do it yourself. Of course, you can do it, but it's a couple of commands if you do it with Docker, or some more commands if you do it with plain container D. But it's actually not only about the system images. So basically you can actually drop even your own application images as a tarball. So we just import whatever we find from there, and it's then rock and roll after that. So this is actually provides you also a super easy way if you have, say you have like a couple of these Raspberry Pi sized devices on your desk or on your factory floor somewhere. Just one way or another ship the image tarball there, and we import the images, and you can deploy your applications. So you don't have to set up all these private image registries and whatnot if you don't really want to. One of the sort of gates for announcing a generally available production ready version of K0S is of course the sort of day 2 operations, like backup and restore being the main ones, of course. So and by backup and restore, what we actually mean by it is more like this like disaster recovery. So say you actually lose your whole control plane, you lose all the etcd data and everything. So we bundled it together with K0S. So both backup and restore are actually like subcommands on the K0S binary. And for the backup, we basically do like a snapshot of the control plane data. And of course, the control plane data means, of course, the Kubernetes API state, which is essentially the etcd data store state. And then, of course, the PKI, the private key infrastructure, the cluster CA, all the certificates and all the keys that are configured on the control plane. And then, of course, restore going the other way is of course full restore of the cluster state. So basically meaning that we actually do restore the Kubernetes API state as is. So on the restored cluster, you get all the same objects that you had previously on the cluster. I'm gonna show that in action too. But essentially that's more like a disaster recovery. So of course you should have highly available setup for your production. So in that case, you don't really have to do like full disaster recoveries if you lose only one of the nodes, for example. So what's still missing on this backup and restore functionality is that currently we don't actually include the SQLite state on the backup tarball. We are planning to do that on the next release. And then this multi-node sort of orchestration for these backup and restore functionalities, we're planning to do that on the next release also on K0S CTL side. So basically you can say that, okay, I have this 100 nodes cluster, but I actually have the backup there, restore it for me, please. Without you having to think too much of things that okay, how do I actually do it? But that's on the next, or at least planned for the next release. We all know that in life, life doesn't always go according to plans. So but that's planned for the next release. All right, so maybe that's enough slideware for today. Let's let me switch to my Visual Studio Code. So as I said today on the demos, I'm gonna focus mostly on the K0S CTL, because I think that's one of the sort of coolest and one of the not really life-saving, but it just makes life so much easier for doing these K0S setups. So basically we have as pretty much all of the cloud native and pretty much all of the tooling nowadays uses YAML as the input. So do we on K0S CTL too. So basically what you have is basically it's kind of a declarative way to manage your and set up your clusters. So essentially we said, okay, we are gonna create something called cluster, and of course the API version, and this YAML actually follows the Kubernetes kind of manifest YAML format quite well. So we're bootstrapping a cluster, and then we give a spec for the cluster. So in this example, this is a super simple example. I have a couple of pre-provisioned virtual machines on my disposal. So basically, I say that okay, I have two hosts. That's the addresses, and that's the user to connect with. One of them is a controller, and one of them is a worker. So super simple setup. If I would do this manually, I would first SSH myself into this controller, do the download K0S, do the K0S install to get the systemd unit in place, then get the token, ship the token to the worker node, and join the worker into the cluster. Well, in this case, cluster. It's a one node cluster, so I'm not sure whether that warrants a term cluster, but yeah. And then for the K0S configuration, I only said that okay, let's use this 121.1 plus K0s.0 version of K0S. All the other configuration I'm going to use is the default, so that's why I don't have the K0S configuration at all in this example. So quite simple and straightforward. So K0S CTL apply -- config, and that's the K0S CTL.yaml. So essentially what K0S CTL does is it connects to the host with SSH. It actually does download the K0S for me on the hosts. I could, of course, for the Airgap setups, I could say that, okay, I have the K0S on my laptop, so upload it actually from there. It does some validation that everything looks correct on the hosts. It installs the controller, it waits that the Kubernetes API is up and running. It generates the token, installs the worker, and now we wait that we actually see the worker node as ready on the Kubernetes API. So it actually does the exact same process I would do manually, but it just, for me it's now one command rather than 2 or 4 or 10 different SSH terminals and whatnot. So this is sort of just a convenience tool to make our life easier. So essentially, now that we're waiting for the node to become ready, we're actually waiting for the node to actually pull all the system images. So let's hope that I don't run any Docker hop rate limits or anything. What did I say about the live demos turning into debug sessions? Yep. So roughly in 2 minutes, I now have the cluster or so-called cluster up and running. So of course I now wanna connect actually my laptop into the cluster too. So what I can do is this K0S CTL kube-config, and then give the same configuration file, K0S configuration file for it. Let me do this other way around. Let me pipe it into kube. K0S demo export kube-config equals kube K0S demo.conf kubectl get node pod -a. Yep. So the worker is ready. I have all the system components up and running, and life is easy with K0S CTL now. And as you remember me talking about that today also, and I remember I talked quite a bit on the control plane isolation feature. So if you see the cluster, I actually specify 2 hosts, but on the node list I see only 1. So this is the control plane isolation in action. So the controller node is that there's no way for me to schedule workloads on the controller node. So it's really sort of isolated from the cluster. I cannot push my random Nginx pod on the controller node and then expose it to internet, because that's a bad idea. So by default K0S always runs the controller as fully isolated from the cluster. All right, so let me take a connection into the controller node. SSH root. Oh, what am I? Root at. Yep. I'm working with Hetzner Cloud, and Hetzner is they super easily reuse the same IP addresses that you've used. Like if you had a box running and then you go and delete the box from the cloud, and then in a couple of minutes you spin up a new node, it's very highly likely that you actually get the same IP, public IP for the node. So my SSH is always complaining to me about things. So, all right. So if we look at the process list, let me close that. If we look at the process list, we see this K0S controller is running. We have etcd, APS, kube API, schedulers, controllers. The whole shebang is running. And let's actually simulate a disaster in our hands, whether that would be an actual disaster or a stupid operator error that I'm about to do. So, of course, first things first, I wanna do a backup. So K0S binary is now there, of course, available. So K0S backup dash config is etc K0S YAML. I always forget this one. Save path. I'm basically saying that, okay, let's take a backup. The configuration for K0S is there, and save it on my current directory. So, of course, in this case, because I don't have many things running, so the etcd backup is actually quite fast, and it's super small too, of course. So we just collect these certificates and all the PKI stuff. We get all the Helm configurations that we've possibly done. We do the etcd data snapshot on the fly. And then we basically dump everything into a single tarball file. it's this K0S backup, and we do this typical timestamp on the file name. So you could then easily push this to your S3 or whatever storage you have on your disposal. Of course, that you have to take the backup file out of the node, otherwise it's not really a backup. So, all right. So let me now I actually do have the backup available. Let me simulate a disaster. So systemctl stop K0S controller. I'm going to stop it first. Yep. K0S reset. So this reset command is actually something new also. So it allows you a somewhat easy way to actually reset your node. So basically wiping out all the stuff from K0S, or at least all the stuff that K0S itself has been doing. Of course, it doesn't know what you've been doing manually or with some automation tools, but essentially, what it does for me now is it removes this varlib K0S. So essentially now I got rid of all the etcd data, all the certificates, all the keys, everything related to K0S. So now the single node that I have in the cluster is now yelling that, okay, well, hey, where did you go? I lost the connection to the controller. So it's going bananas there, but that's okay. That's life. But I do have the backup available. So to get everything up and running again, what I need to do is K0S restore. What's the format? K0S backup. So basically it reads the tarball file. It adds this, gets the certificates and keys and everything out of the tarball and puts it to the expected location. Why don't, did I forget one attribute? Let me see, lib K0S. So it also, of course, restores the etcd data from the backup snapshot. So what I can do now is K0S install, because I want to get the systemd unit back into place. And this is actually something that I've been thinking that maybe we could actually do also as part of the snapshot is to take also the systemd unit file, so that we wouldn't have to do this install command separately. K0S YAML. Yep. Systemctl start K0S controller. K0S kubectl, and this is the what I mentioned, that we've now embedded this kubectl commands into the K0S binary itself. So I can do this get node pod -a, and you see that I have this workers again online, and as you see, the pods are still up and running, and as you see, the pod age is actually 10 minutes old. So the pod object on the Kubernetes API is exactly the same object that we had before I went and deleted everything. So this is really a like a full restore of the data on the Kubernetes API level. So all the objects have the same UIDs and everything. So this is really a raw full restore of the data. All right. Okay, everything's up and running. So I was able to actually recover from a manually made disaster. So I wish the evergreen incident would have been this easy to fix. All right. Another as I mentioned, one of the cool things with K0S CTL and sort of how we designed it is that it's actually quite easy to integrate with infrastructure automation like Terraform, for example. So in this example, I have a basic Terraform stuff for Hetzner cloud. So I'm gonna spin up a bit bigger cluster. So I'm gonna spin up 3 controllers and 3 workers. And as we have stated in the documentation, so if you want to have highly available control plane, it's a requirement that you have a load balancer for that. Of course, I mean that's just how life is. You really need to have something that balances the load out for the different controllers. So they're just going to be standard Ubuntu boxes. The CX31 is, if I remember correctly, that has like 2 CPUs and 4 gigs of RAM. And yeah, there's going to be 3 controllers, 3 workers, and then this load balancer, and then this load balancer connections configured on Hetzner side. There's nothing really super fancy about this. What is fancy is that we used this Terraform output capabilities. So basically, as you see, we actually construct the K0S CTL YAML-like structure in the Terraform output. So we have the API version, the kinds. We loop and collect all the hosts. We select that, okay, what's the role for this host? We say that, okay, this is the K0S version that we want to set up. And then we give a bit more configuration on K0S itself. And in this case, basically what we have to do is we have to configure the load balancer address as the external address on the cluster. So that basically it tells the different components, like for example, for kubelet, that okay, connect to the load balancer rather than connecting to a single controller. And of course, the same goes for different other components like kube proxies and whatnot. And then, of course, we need to have the load balancer address as the sans, so the subject alternative names on all of the certificates. So other than that, I'm going to go with the defaults with etcd and kube-router as the CNI and whatnot. So change directory to Hetzner Terraform apply. It's gonna create 12 resources, so sounds about right. I trust it. I remember last time I said that this is usually fast with Hetzner, and then it took like minutes. Now it's actually like it usually is. So, and this is one of the coolest bits with working with Hetzner, and that's why I want to use it always on my demos, because I actually created 6 VMs plus a load balancer configuration and everything, and it took like 10 seconds. So it's really blazingly fast. So let me grab my all right. So what I'm going to say do is now I actually take the Terraform output as a raw YAML. So in my output section, I basically have this YAML encode of the HCL data structure. So I take the raw output, and then I actually pipe it to K0S CTL. So, and then, oh, this is wrong command. Apply. Yeah. And then I said that, okay, K0S CTL, let's apply the configuration. And this is the standard Linux shell thing to indicate that, okay, we're actually reading the input configuration from the pipe. Let's remove this part. Oh. And it does the same thing. It connects with all the hosts. It downloads everything, the K0S version for me. It validates the host that the hosts are in a state that we can actually put K0S in place. And as you know, K0S has very little dependencies on the OS level, so we don't really validate too many things. It sets up the first controller, waits to see the Kubernetes API up and running. Then it generates the join token for the controllers and starts to join the controllers one by one, and always waiting that the K0S service actually comes up and Kubernetes API comes up and everything, and then moves on. There's actually an annoying small bug on this part, which is planned to be fixed also on the next release. So this joining always the second node takes unnecessarily long time. I have it on my to-do list to fix. It's probably like a 2 hours thing to do, but it's not actually blocking everything and everything works, but it's just annoyingly long. So during this setup, when we set up these multiple controllers, so first we set up the first one with etcd data store. We generate the token on that node, because that once we have the etcd and kube API, that the first controller is actually operational already. So basically when we join the second node into the controller cluster, we actually expand automatically the etcd cluster. So we actually go and reconfigure etcd that, okay, hey, by the way, you have another member on that node, so connect with that and peer with that automatically. And so on. So you can basically go and add more and more controller nodes too easily with this join tokens and with the same process. Of course, etcd does not scale linearly, so don't go and add 200 nodes on the etcd cluster. But I think it's quite typical to have like 3 nodes or 5 nodes. I have seen some cases where they run like 9 nodes on the control plane cluster, but I don't know, that starts to feel a bit too much already. So all the controllers are up and running, and now we see that it's actually doing the worker join part already first. And this is one of the nice things with K0S CTL. So of course with controllers we have to do it one by one, because we have to, you cannot say to etcd that, okay, you have now 1 node, let's expand it automatically to 100 nodes, because etcd doesn't really work that well on that sort of phase scenario. So you actually have to add 1, wait that everything comes stable, then add 1, wait that everything comes stable again, and so forth. But for the workers, we can actually say that, okay, all 100 nodes go and join. So we can do that in parallel. And that's also what happens with K0S CTL. So it actually operates basically everything as parallel as possible. So that's what actually makes it quite fast even. So it took me like 3 minutes, and when we fix the bug, I think it's actually going to be closer to 2 minutes. this type of a setup. Config. Let's take the kube config and then pipe it into kube K0S demo. kubectl get node auth -a. What? What did I say about the live demos turning into debug sessions? I have on my others. Okay. It may be it just took for a quick while for the load balancer to actually on Hetzner side to become ready and actually have stable connections with the controllers. So yeah. So all the nodes are actually ready, up and running. I have all the system components running and everything, and voila. That's K0S CTL and with the highly available setup in action. So K0S CTL really simplifies this sort of a setup. So I would highly suggest people to use it if there's no obstacles of doing so. All right, I'm running out of demos. Anything specific you would want to dive into or see?
Yes, definitely. I think there are a few questions.
Okay.
I think, and if you have more demos to prepare, you can do it now. I ask questions.
No, I don't have any more demos up, but I can dive into some of the details if you want, or if there are specific questions.
Yeah. I think we dive a bit on the first on the Apache environment you set up. I think the first thing that we do, the clusters, the controller planes are up and running one at a time, but the worker nodes are parallel to the controller nodes.
Yes.
They don't wait the controller to come up and then join. They join immediately to the three controller node.
Yep.
And one thing I think that, do the tokens that we have for the one controller, do they have another controller? They have to join? How the process of joining between controller to controller in a three HA setup?
So let me scroll to the logs. So basically the first things first is, of course, to create the first controller and have that up and running. So for the second part, for the controllers, we actually generate a token. So if you follow the logs and the IP addresses, so this the .46 is actually the first controller address. So we connect to the first controller, and at the first controller we create the token. Then on the second controller, which is the .18 address, we write the join token as a file on the file system. And then we basically start the K0S controller and say that, okay, by the way, you're going to join an existing cluster, read the token from that file. And the token actually has enough information to tell to the K0S process that, okay, where is the first controller? Where do I actually have to call to connect myself into the cluster? So basically it calls to the first controller and says that, hey, this is my token. Can I join the cluster? And once the first controller sees that, okay, that is actually a valid token for joining a controller, the first controller connects with etcd, and resizes the etcd cluster, and then gives back information about the etcd cluster. That, okay, for the etcd part, there is this existing node with this existing address. Configure your etcd to connect and peer with that, and so on for basically all the nodes.
Yes, definitely. I can understand that. I think it's a so etcd to etcd. We need to in a three HA setup. We need to have a etcd to etcd communication, because the load balancer is on the front of them, and then the kube API server in front, instead of talking to the etcd and other guy, they talking to the load balancer, and then the load balancer decided which etcd and which controller plane it's need to talk to, and one of the node is down, then the load balancer is switching that to the another controller.
Well, almost. So actually in K0S, the etcd is not exposed at all out from the nodes. So we don't connect the etcd with the load balancers and everything, because that's pretty private information. So you don't definitely want to have that available on the internet. Let's put it that way. So actually on each of the, let me connect with one of the controllers, and let's see. SSH root at this address. Yeah, I trust it. What's the PID number? Proc. Wrong process. Sorry about that. I'm interested on the kube API server. Can't proc this PID and the command line options. That's. I'm trying to find the, yep. So here you actually see the etcd configuration. So we always tell kube API that connect with etcd only on the local node. So a specific kube API server instance connects only with the same etcd on the same node currently. Okay. And that's actually by design. So because there's a load balancer. Let's say that I'm doing commands with my kubectl. So my kubectl is actually connected to the load balancer, and that spits the traffic to the three different controllers and thus three different API servers. So there's no need to distribute the load to another load balancer to different etcds anymore, because we already did the traffic distribution and routing on the first load balancer level.
Yes, definitely. And I think the next question is on the backend restore side. Do you restore only the etcd part of that, or the kube API server as well? And also on the topic of backup and restore, do we see some kind of, let's say, some project velero and from the VMware, they have built out some tool to backup restore side. Do they can integrate with K0S? A project can integrate with those projects like Velero to upgrade to backup and restore kind of capabilities.
Yeah. So for the first question, yes, we do restore the full Kubernetes API state, because that is what is in the etcd data store. So and I really have to always emphasize that it's really a raw restore of that full data. So you get all the same object, you get same nodes in the cluster and everything. So if you really lose also your worker nodes, then you really have to think that do you really want to do this restore this way or maybe in some other way. So if you actually plan to restore the exact same cluster per se. What comes to tools like Velero, which is actually a super fantastic tool, and it's actually saved my life in the past couple of times even. Yes, we of course integrate. Well, we don't build any specific integration with Velero, but of course you can use Velero with K0S. So and I think that's one of the coolest parts with Velero is that it actually operates with Kubernetes interfaces and Kubernetes constructs. So it doesn't actually require anything specific from the distro that you use it with. So you can definitely use Velero with K0S.
Awesome, that's a great news. And the third question on the part of, I think the last time we first did a session back then in January, you draw some pointers on then one new thing that I see in the K0S when you hit the kubectl get node, the connectivity agent. We are familiar with the API server, etcd, scheduler, controller, but people are not familiar with the connectivity agent. What is happening? What is connectivity agent and what it's doing?
All right. So let me do a demo. So kubectl get node pod -a. So this is the 3+3 configuration that I created. So the connectivity agent is it's an agent that connects with the control plane. So essentially, I'm thinking. Let me think. Yeah. So essentially, the agent running on the worker node, it takes a connection to the controller node and creates a sort of a tunnel. And then what we do actually on the controller node, there's an API server process running. So we actually configure the API process with a configuration that says that, okay, every time you need to connect to the cluster workers, mostly with kubelet, of course, actually connect to a local Unix socket on the controller node, which is the connectivity server component. And that actually pushes the communication to this tunnel that was actually initiated by the agent. So it uses this sort of a, like almost a thing that you often can do with SSH, these reverse tunnels. So it's a similar kind of a pattern that the agent really opens up a tunnel, and then the Kubernetes API actually connects to the nodes through that tunnel. So if you think about this like IoT and edge type of cases, in quite often, at least in those cases that I've seen and been working with, there's quite often a requirement that the worker nodes are running in some private data center, or maybe on some factory floor, or maybe on the edge network where you might not really have a like internet type of a connectivity from there. So essentially, you also need to think that whether you really want to expose the kubelet port, for example, for really outside connectivity. So essentially, this allows to use these backwards tunnels to still enable the connectivity between the API server and the worker node components, like kubelet mostly.
Yes.
Let me show it how we actually configure it.
So what I understand that I think that when the Kube API servers talk to the kubelet, so there's a back and forth communication happening between all the time. And that's really
Yes.
a painstaking task, because every time you talk to API server, kubelet talks to API server, API talks to kubelet. Instead of having a back and forth communication happening there, instead of generating a tunnel, and every time the request is made to the API server, made request to the kubelet, it's using the same channel before integrating the new connection with it.
It's actually only used from the API server to the kubelet. So kubelet is still connecting directly with the API server, or well, actually in this case, the kubelet is configured to connect to the load balancer.
Okay.
But this is kind of on the other way around. So let me see. Cat war leap K0S Konnectivity conf. So this is basically the configuration that we give to the Kube API server. So this basically says that okay, whenever you need to talk to the cluster, meaning the worker plane, basically use gRPC protocol and connect with this Unix socket. So this Unix socket is actually where we sort of terminate the agent connections on the control plane side. What this allows us to do is setups where, for example, in my local test bed here on my actionable, and as they are connected on my home network, I don't expose the kubelet ports to of course the outside world. So what I'm able to do is I can actually run the controllers for those in the cloud provider, and then from the cloud provider I connect my kubectl with the control plane there, and then through this reverse tunnel I can still connect and get the logs and everything from the nodes.
Yeah, definitely.
So this really is K0 kubectl get pod minus a. Let's take, for example, core DNS. So one of the typical use cases where the API server needs to connect with the kubelet is to get the logs of a pod. kubectl minus namespace kube system logs and core DNS pod, and yeah, I get the core DNS pod logs. So if you have like a sort of a disconnected network between the control plane and worker plane, you wouldn't be able to do that. You wouldn't be able to get logs or exec yourself into a pod or do these kubectl port forwards and whatnot. So that's why we have these connectivity components in the picture.
Yes, definitely.
So that's one of the magics of what K0S actually does.
I think it's an open source project guide. Is a kind project. That I think also the K3S is using for that. I think it's a similar to, it's a kind project and somebody using for that tunneling.
No, Kind is providing this sort of a what's the term that they use? Kind of a shim like process. So where kind of exposes etcd like interface for the data, and then on the backend you can actually have like MySQL or something else as the data store. So kind is very, very different.
Okay, good, get it. And I think the next question before we let you.
So this connectivity stuff. Connectivity stuff is So this connectivity stuff is a special interest group, a server proxy, something. Yep, you were saying something.
Yeah, I think the next question, before I let you go, you spent a very good amount of time with me explaining these kind of things. And the one thing I think the people would like to know about, there are some distros in the Kubernetes world, they're using systemd services. And when you run those Kubernetes distribution on a system that don't have systemd services on other kind of dependency, you won't be able to run those Kubernetes distribution outside of these Linux environment that don't have some kind of systemd services. So I think the K0S is having no dependency in any kind of a Linux host operating system. And can you draw some points on some things on
correct
systemd and dependency with Linux operating systems?
So yes, that is true that we don't systemd or not, because that's not our choice. So and there are I don't know, plenty, but at least there are a few distros that, and I think that's a good thing. That's my personal opinion. I'm a fan of systemd. One of the most common, of course, is probably Alpine Linux, which has this OpenRC in its system. So install command, which is able to inject the systemd service unit file. So this is OpenRC. So it is actually able to also detect that hey, this system is actually based on OpenRC, and it'll inject the OpenRC image scripts into place too. But if you have something else, like if you have like something that uses maybe upstart or sysvinit or something super custom, then you can, of course, you can K0S, it's just a binary, so you can integrate it with any init system quite easily. Did that answer the question?
Yes, definitely. It's really, that's what I was looking for. And I think one last thing, you draw some use cases of the Airgap installation, because I think the K0S and all these kind of distribution has these advantages that you can run on the IoT devices on small setups. That's a really use case of these K0S and K3S kind of use cases. I think you can draw some point and use cases why you want to use Airgap installation and what is the benefit of that.
Yeah. Okay. So in most of the IoT type of use cases that I've seen in real life for Kubernetes, the clusters are actually running in environments where you don't really have connectivity to pull images from cloud, let's say from Docker Hub or Creo or any other public repo. So and then in some cases we don't or people don't really want also to run their private registries for images, because that's another thing to maintain and do and sync the images and whatnot. So especially you definitely don't want to spend your first week to setting up your private registries and whatnot. So we wanted to make it like super easy to spin up K0 also in these image bundle import functionality. Just to kind of take some friction out from the setups. Of course, if you are planning to run like a full scale all you need is strategy in this sort of environments and effort into setting up private registries and whatnot. Of course, it probably makes a lot of sense, but at least we have some of the friction from the early trials taken away with this image bundle thing.
Yes, thank you very much, Jussi, for explaining all these kind of things. So I heard during this 1 hour and 30-minute session, I enjoy so many talks learned so many things. We last met, and I think that one thing that I learned about today, the K0S CTL is one of the best use cases to spun of K0S based clusters. And it removes all the pain you already have during these kind of setups of configuring, managing, and deploying K0S clusters. And you have to learn about what the K0S CTL does. And today we show how you can use K0S CTL with Terraform of managing and deploying your infrastructure in just a minute using a Hetzner cluster. You can do it for all kind of other cluster as well. So before I let you go, can you wrap it all the discussion that we have today?
Yeah. So of course, as usual, we have the docs available. We have the main projects is of course on GitHub, the K0S project itself, and then K0S CTL project also. So both are fully open source. So if you hit any issues, just let us know if there's something that doesn't work on your specific environment or specific use case, or if there's some feature missing that you think would be cool. We have a dedicated Slack channel with on the Lens Slack. So Lens is kind of a neighboring team here at Mirantis. So we share the same Slack. We didn't want to create yet another Slack dedicated for K0. So we borrowed a channel from them, and if you want to have more interactive discussions, so join that Slack, and that's where the information is. So. Yeah. I think with that, I thank you for the time, and maybe after the summertime we can see again that what's new. We have some cool things planned for the upcoming fall time for the new features and whatnot. Then one of them being a super cool integration with Lens, actually.
That's awesome. That's I'm very looking forward to. So thank you, Jussi. We plan every time we see a new big release and one of the major releases on the K0S, we try to engage with you, and hopefully we can do it in the future as well. Every time we see a new release on the K0S team, and then I will interrupt you, having a session with you, what these kind of cool sessions are. And tonight what you saw, you really inspire me, and I'm really looking forward to running these all kind of setups in my laptop after the session. And every time we see a new release, we try to ping Jussi. He's a very good person, and he take his time, and I really have thankful to them. He's showed his interest, sharing his knowledge, because he's super busy, because you all know the distros world are super busy all the time, because you're competing with others, you are doing some Linux, and there is so much going on. But I think, Jussi, thank you very much for your time.
No worries.
Try to connect with you again in the future. Bye everyone. Stay safe and stay healthy.
Goodbye.